Bobby Watts from Encore RC, and this is the Invertix 400, one of the world's first 3D fixed pitch multi-rotors. So what does that mean? That means that this guy will go upside down very easily. This happens with the instantaneous motor reversal process. So here we've got some special speed controllers and some special propellers that allow us to achieve inverted flight simply by just flipping it upside down with our controls, and the motors instantaneously stop and go the other way to achieve inverted flight. So what does this mean? This means that you can practice your inverted flight, inverted hoverings. You can actually fly it just like a helicopter. You can pull off maneuvers like tic-tocs, pirouetting flips, funnels, hurricane. Anything that you can do with a helicopter, you can do with this guy. But the nice thing is that it's so simple. There's not many parts, not many moving parts at all, hardly, just 4 moving parts, just the motors. The frame's very simple, very robust, very strong, and we tried to make it as plug and play of an experience as possible. No soldering required if you're using our XT60 battery connection. If not, it's just one battery, little battery you gotta solder. But that's it. It's a plug and play experience. We wanted to make it very straightforward for you. So here I've got some kits, and I just wanted to go through the build process of this, also the test flying and the flying experience with you as well. So sit back and enjoy. So let's take a look at what's in the box. So I removed our cover here, nice box cover. Now we've got our box. Let's check it out here. Let's see what we got in here. Invertix 400. Okay, so the first thing that you're going to see is a pre-painted canopy. So this one I've got here is an orange one. We tried to make sure it comes nice and protected, so that when you get it, your high quality canopy is here in one piece. So once again, you can choose the colors on our website when it's time to order, whatever tickles your fancy. So as you can see here, pre-painted canopy. Okay, next we've got the manual. This one we spent a lot of time on here. A lot of time in this manual. We wanted it to look nice, but we also wanted it to be as informative as possible. So that way you can just build it if you're at a fun fly, build it with your buddies, build it one night, and hopefully not have too many questions. So we've got the manual here, shows you everything that you need. Now we're going to walk through this step by step for the build video here. So I think that that will be pretty helpful for everybody. So printer manual. Next is the decal set. This is coming for our painted canopy here. Now the decal set that comes might vary. We've got a few different suppliers for decals, and they all say the basic thing. They say Invertix, shows the windscreen, that kind of stuff. So I'll show you where the stickers are supposed to go. So next, take out this stuff. Okay. First thing we'll see here is our receiver setup for the NanoWii. So this one that I've got here, this one is for the Spectrum. It's got an S. You can see when we write the date on it, when we program it, when we flash it, and it's for external receiver or Spectrum. So this one right here is for the Spectrum. Now this one also includes the cable for the NanoWii board to go to a Spectrum satellite here. And as you can see in here, we've got our NanoWii itself right here. So this is the NanoWii. Okay. Now also, just for the sake of showing everybody what it looks like, I also included a external receiver NanoWii in this one. So in this one, when I pull it out of the package, you will find 4 wires that is just like a signal wire, where these plugged into your signal ports on your external receiver for Futaba Hitec JR users, as well as a male-to-male connection that goes to your throttle channel from the NanoWii, and as well as a pre-calibrated, ready-to-go, pre-soldered NanoWii flight controller. So it's one of 2 versions. Both will not come in the kit. You have to select external receiver or Spectrum satellite version. So that's our satellite version there. Okay, next is the frame. We offer 2 different types of frames. We offer carbon fiber, we offer G10. Carbon fiber, we charge $29.99 more. You'll save about an ounce, and it's noticeable. It's noticeable in the air. So for those hardcore 3D guys, if you want to go for the most power to weight, the carbon's the way to go. But the G10 flies just fine. It's about half the price for the replacement parts. So So you can see here, we've got some different carbon pieces. We've got the, okay, let's get them lined up here. It's pretty simple, not too many parts in this kit. So starting on the biggest pieces, we've got the frame. So this is the top frame right here. We've got the bottom frame right here. We have the battery plate right here. We've got 4 frame braces that interlock. We've got 4 landing gear, so just skids, and we have a frame protector plate, which protects the NanoWii in any hard crash when you land on the top. And thanks to our crash test buddies here in Florida, they made sure that this plate was there in the kits because they were destroying stuff before we had that. So that's the frame. Once again, carbon or G10. It both of them are, you know, whatever you want to do there, that's up to you. It's completely up to you for the choice. The G10 and the carbon both look great in the kit. So next is the arms. These are our square aluminum arms that are pre-drilled, pre-cut, ready to go. 4 of them in a kit. It's got the holes here for the motor, 2 holes for a canopy, and 2 holes here to mount into the frame. Okay. Next is our power distribution board and our BEC. So a power distribution board simply allows our speed controllers to plug right into it. And we've got a XT60 connector here for a battery. So for those of you who are not using an XT60, you gotta swap it out to a Dean's or an EC3 or whatever else you use. And also we've got the Outlaw Power 2.5 amp 5 volt BEC and a very simple connector that allows you to plug it together with no soldering necessary. So very easy here. Try to make it simple for everyone. Okay. Next we've got our hardware bag. Pretty simple, not much hardware here. 3 different sizes of socket head bolts, some plastic spacers, some grommets, all sorts of stuff. Everything is in here. Now, for those of you who've been in the industry for quite a while, or been in the hobby and understand what building's like, we're not perfect when we put the kits together, so we include a spares bag. It's a few of all the bolts and everything in the hardware package. So if you drop one on the floor or if we miss one, whatever, we got you covered here with the spares bag. So that should be all for hardware. Next are our Neo 8-inch propellers. These are the 3D Neo propellers that come with the kit, and we even include 2 sets for you. So your first crash is on us. And a lot of times guys need these just to get their model in the air with some trouble or having something backwards or something. So these come in a set of 4, so 2 clockwise, 2 counterclockwise. And this is it. Next is 4 of the Outlaw Power 25 amp reverse 3D ESCs. So as you can see here, it's pretty simple. We've got the 3 wires that go to the motor. We've got both the power wires with the banana plugs on there that plug right into the power distribution board. And we've got the signal wire that goes into the NanoWii. And we've also got another wire, a yellow wire, which is just used for updating firmwares. So this speed controller is updatable. Now, another thing that we've got that's pretty special is our Outlaw plug and play LEDs. So this does not come in the kit, but you can certainly add it to your order. And it's sold in a set of 2. And it's very simple. It's just an LED that goes on the Multirotor that plugs right into the speed controller very easily. So this plug here on the LED plugs right into the speed controller and it lights it up. So if you want a night fly, you can add 2 of the LEDs to your order. So like 2 colors for the front, 2 colors for the back. You can choose your colors. And it allows you to night fly without having to solder or anything. We've noticed some guys prefer the LEDs as well during the day for even more orientation, but that's completely up to you. So that's our LEDs here. So for this kit I've got a blue LED set and a green LED set that I added. Lastly, we've got our motors. So these are the Outlaw 2212 1400 kV motors here. Pretty simple, not much to say about that. So that is what's in the box here. Our box is now empty. And now let's start the build. So we're going to start on page 1. And feel free to browse through the build video here. I'm going to list them out in certain steps so you can skip ahead if you didn't have any questions for certain steps or whatever. So feel free to use the timeline at the bottom to click on to wherever you need some help. So we're going to start with the build here on page 1, and here we go. Let's get into the build. Let's take a look at the manual here. So I've got our printed manual. Take a look. So we've got the table of contents here, so you can see. You need to fast forward through anything. Nice little welcome letter from us. Once again, we encourage you guys to really look at the manual step by step. This thing's really different. We've put a lot of them together too, so we've got the method to the madness here. We know how to put it together. So really pay attention to the manual. The build steps are important. It just prevents you from having to do things over again. So next thing we see here on page 3 is required components to complete assembly. So that's a receiver or a satellite and a battery. It's really about all you need. So once again, for Spectrum guys, you need a satellite that is pre-bound to a model. So this means that what you need to do is you need to set up a new model in your radio. You then need to, a helicopter model. So you set up a new helicopter model in your radio. You then need to bind your satellite with a receiver. Then you unplug it. Then you can plug your satellite into our NanoWii and go fly. Unfortunately, with the NanoWii, we cannot bind your DSM2 or your DSMX satellite there. So you must bind it first before plugging it into the NanoWii. So you will need a receiver with a bind plug in order to do that. For external receiver, guys, you're going to need at least a 5-channel receiver. Easy enough. Lastly, you need a battery, like a 3S 2200, 2600, somewhere in there we're finding is a really good battery size for that, for the Invertix. Next is the necessary building tools. You can see here we've got them all laid out, and look, I got it right here, everything laid out. So you need some blue thread lock, some super glue or some CA, like a medium CA is about best. Some double-sided foam tape. This is going to be used to mount your satellite or your receiver to the airframe. Next, we've got a 2.5mm hex driver for the 3mm bolts. Next, we've got a 10mm nut driver. This is for the propeller nuts. Next is a 5.5mm nut driver for various bolts on the frames. And lastly, a 4.5mm nut driver. Now this one's a little bit less common. You can really use pliers to substitute this. It's really not too big of a deal if you need to use pliers instead of that. So those are our tools. Next is step 1, so let's go to step 1. So here we go. Step 1, frame support bracket assembly. Quite simple here. So here I've got our 4 frame support brackets, either carbon or G10. Now, due to the suppliers of our carbon and our G10, the thicknesses vary more than I'd care for, honestly. But we do what we can. So some of them you're going to find a really snug fit. Some of them you'll find a nice fit. Most of them will be a really nice fit. Some of them is a pretty loose fit on there. But we've made it in such a way that you can just put it together. No tools required or anything like that. If it's a little tight, we recommend you just kind of tapping it on a flat surface and it'll go in. There should really be no need for sanding on this. So you just take the 4 frame support brackets and you put them together as the manual instructs. So you put them together like this. This is going to go in the middle of the frame and really brace the top frame and the bottom frame to eliminate flexing. Step 1. Now time for step 2, the hex post installation. So referring to my manual, just a note here, anything in the red in the manual is more of a explanatory, or just some advice, like, hey, take a look at this. So anything in red is really worth looking at. All of our part numbers are in orange, so it makes it easier for when you need to order some spare parts, and explains what everything is. So we've got our top frame here. So what we're going to do is we're going to install the 4 hex posts onto the top frame to hold the multi-weight. So now you can just dump your hardware package out. You can sort through everything if you wish. There's not too many different bolts and stuff in the kit, so it's pretty easy to do on your own. So now it says note the forward facing arrow and the front hole is to the right. So this arrow, as you can see right here, denotes the front of the aircraft. Make sure you get this right because it can bolt anyway, but make sure it's the arrow points to the front. So this will help you tell which way is the front of the aircraft when the canopy's off. Once again, front hole to the right. This just makes it the same as the manual. So this is where your speed controller wires go through, actually, right here on this front right hole. So this is the way we're going to do it. Now we're going to take our 4 hex posts, our 4 plastic hex posts, as you'll see right here, with a 3x6 bolt from the bottom. We're going to put it together on the innermost holes right here. Also a little bit of CA glue, because we're putting metal into plastic. So we're going to use some super glue or some CA, whatever you got here. And we're going to secure it with the 2.5mm wrench and the 4.5mm nut driver. Tighten them up. There we go. Step 2 completed. Now time for step 3, frame support brackets installation. So referring to the manual here, what we're going to do now is we're going to insert the frame support brackets in between the top frame and the bottom frame. Once again, on the bottom frame, please take a note at this forward-facing arrow. We want both of the arrows to line up on the top frame and on the bottom frame. So you want them to line up nicely like that. And what we're going to do is we're going to put the frame support brackets in between. So holding that, we're going to put the frame support brackets on the bottom frame first, and they will wedge into the slots in the bottom frame pretty nicely like that. Okay, should be a nice little click. Now, just holding our fingers on there, we're going to put the top one on. And we're just going to get all of them just kind of lined up. We're not tightening anything here. We're just putting them in position. So you can just wiggle it around until the frame supports go into the slots in the frames. And so there we go. So that's just lining it up. So that's step 3 right there, getting everything lined up. So now step 4, we're going to install the power distribution board. So we've got our power distribution board here with our jumper that goes to the BEC. Now what we're going to do is we're going to install this so that the wire comes out the back of the model. So if I pick up my frame here, without having my cross members come out, if I pick up my frame and I rotate it upside down, once again, the forward-facing arrow denotes the front of the model, so the back is this way. So we're going to install the power distribution board in such a way so that it goes just like this. Forward-facing arrows, wire comes out the back. Kind of helps, it looks like the tail. So what we're going to do here is we're going to take the M 3x20s, the 3x20 bolts. We're going to put it through the board here along with 4 of these little plastic spacers. This is going to stand off the board from the frame. So these little plastic spacers are going to go through the board, through the frame on the holes, and out to the top frame. So we can screw it up here, and it'll go just like this. So we're going to do that 4 times. And we're going to use a little bit of blue Loctite, and then we're going to tighten it on with a hex post. This hex post is what's actually going to cover our NanoWii. So this is going to be like a little protector plate up top. Now, as you see in the manual, please do not tighten with a wrench at this point. Just tighten with your fingers, because we need to leave a little bit of room in the frames in order to get the skids in the following few steps. So just put on all 4 bolts, finger tight at this point only, and you will have step 4 completed. Bolt, spacer, Loctite, hex post 4 times. Once again, let's triple check. Forward facing arrow, wire comes out the back. There we go. We've installed all 4 hex posts, and the power distribution board is in the center, just held in right now. Finger tight. Step 4. Step 5. We're going to install the Velcro onto the battery plate here. We're also going to install the battery strap. It's very important that you install the battery strap now, because if you do it afterwards, it is a pain to get through the frames. You can do it if you have some hemostats. It's definitely easier to do it right now. So we've got our Encore RC battery strap here. The plate you can put any way you want. So we're just going to feed it through. Back around. And then we are going to put the adhesive Velcro on the airframe. I always choose to put the angry side of the Velcro. We all know there's 2 types of Velcro. There's the 2 sides. There's the angry side, which is the hard side, and the furry side, which is the soft side. So we're going to put the angry side on the battery plate. Just like that. And then if you want to, you can tighten up the strap here to make your assembly a little easier. Now when we install it, the side with the loop is going to go underneath the frame. So that's it. Step 5. Step 6. Now we're going to install the landing gear and the battery plate into the frames. So we're going to take our frame. We've got the top of the frame here. So we're going to flip it upside down. So we got the bottom of the frame. Now what we're going to do is we're going to install each skid one at a time so that the battery plate can be held in just like this. So once again, the strap side is going to hang underneath so that our battery can be strapped on from the underside of the model. So the way that we install the frames is we insert them right onto the outside of where the frame support bracket has already been installed. And because we only finger tightened the power distribution board, the carbon's got a little bit, the frame rather, has a little bit of room to flex here. And this is going to help you install it. So it's pretty easy. The skids go in this way. Once again, they're going to go in a position here. They're going to wedge in between the frames just like that and fit in very nicely so that when the model sits down, the power distribution board is on the bottom of the model. So if you want to take a look this way, this is how the skids go in. So it's 1 skid at a time because of the way the battery plate is installed. So what we're going to do is install 1 skid first. Now we're going to slide the interlocking carbon of the battery tray onto the skid. Once again, sometimes these frames can be a little tight or a little loose. Either way, it's totally fine there. I mean, if it's super tight, you might have to sand on it, but you really shouldn't have to. We try to get the fit dead nuts here at the factory if we can. So we have 1 installed. Now we're just going to simply go around in a circle and install the others. So now it's time for the second one. I'm going to take the second skid. I'm going to wedge it in between the top frame, while at the top frame and the bottom frame, while at the same time allowing the skid to interlock into the battery plate right down here. So it's kind of doing 2 things at the same time. So it's sliding it into the frame up top and sliding it onto the battery plate at the bottom. So there you can see I just got my second one. Go around for a third one. kind of spread the top frame and the bottom frame with your fingers as you then slide the skid into the battery plate. And it should just kind of slide in just like that. Okay, and the fourth one. Keep in mind, you have to do these one at a time. You cannot do 4 at one time, but one at a time. So now we've got it installed. So now the model has feet to sit on. Now the way to make sure that everything's aligned properly, as you can see on the bottom right of page 10, is to take a look at the holes here on the battery plate and the top hole here where the arm gets bolted in. And you just want to kind of shift it around until they're concentric so that they line up exactly on each other. And this way you're good. You can also tell by looking at the top, if you look at the frame support bracket and the skid, the rounded corners should be lined up just about right. That's how you can make sure it's absolutely lined up perfectly. That'll get everything pretty well set in there. So now we just installed the feet and the battery plate. Step 6. Step 7. Now it's time to install the 4 aluminum arms into the airframe. Pretty simple. Once again, the arms can go either this way or that way. There's no top to the arms or bottom to the arms. Just make sure that you're bolting the correct bolts into the frame, and you're going to see the slotted holes and the big hole out on the arm for the motor to fit in. So what we're going to do is we're going to put the arm in the frame with a M3x20 bolt. Once again, this is one of the longest. This is the longest bolt that's included in the kit, and we're going to put a nut on the underside using our 5.5 millimeter nut driver for the 3 millimeter bolts. So we're just going to do one bolt at a time and work our way around till we've gotten all 8 bolts. Now that I've tightened up all of the bolts on the arms, all 8, you can see the frame is much stiffer now. Should squeeze the legs together, and there shouldn't be hardly any play here. Lastly, what we're going to do is we're going to fully tighten the bolts from the power distribution board that go into the hex posts up top. So now is a good time to fully tighten that with our wrench, because we had previously just done that by hand. So we'll tighten them up now. Okay, step 7 is now complete. Arms are now bolted in. We tighten up the power distribution bolts. Step 8. Now it's time to install our frame grommets. So pretty simple. We got 4 big frame grommets here. They're going in the holes on the top frame. This is going to prevent any wire chafing as the speed controller wires go through the top frame. So I usually just push them in, and if you need to, you can run a small screwdriver around the inside of it to get it fully seated on the frame. So as you can see here, this one, give it a little bit of wiggle like that with our screwdriver. And we've got it well into position here. Now, very lastly, there's a red note at the bottom, so page 12 for our manual here. There's a note where you can check the play in your skids. Once again, depending on our manufacturer, the thicknesses vary just a little bit, just enough to make a difference. But if you want to tighten this up here, now's a good time to apply some CA glue to this corner here where the skid meets the battery plate. So the 4 corners right here, and if you add a little bit of CA, if your kit happens to be a little bit loose, which is fine, it's not going to hurt anything at all. If it's just a little bit loose, you can add a drop of CA right here, tightens everything right up. And it still makes it easy enough to where if you break a skid and have to pull it out, you can still remove it. So just a little bit of drop of CA right there, and you'll be in business. So that is step 8. Step 9. Now we're going to install the flight controller. So we have our NanoWii right here, and it's pretty simple. There is a forward-facing arrow on the NanoWii. You'll be able to look at the top, there's a forward-facing arrow. So what we're going to do is we're going to line the forward-facing arrow with our forward-facing arrow on the frame. So the arrows are always facing forward. It's the nose of the aircraft. So in the manual, we have these 4 little rubber grommets. They're tiny, these tiny, tiny little things. And what this is going to do is this is going to isolate any vibrations that might come through from the standoff post to the NanoWii. So we're going to put 4 of the grommets on here, on the plastic standoff post, on the hex standoff post that we did earlier. And we're going to place the flight controller on top. Once again, just to reiterate, arrow should face forward on the NanoWii and on the airframe. Lastly, we've got the 4 3mm hex nuts. They're just the little tiny nuts, the black tiny nuts that come in the kit. And we're going to screw them on. I think it's easiest to just do it by hand first. Then you can tighten it up with a 5.5mm nut driver. Very lastly, we're going to put some CA on the top of the nuts just to keep it from coming off in flight. We don't want that. Keep it from coming loose. So I recommend getting them started by hand. Just makes life a little easier. So as you can see here, we've got the nuts on there, and we're just going to tighten them up. And you can feel free to snug this down a little bit. You don't need to over torque it, but you can snug it down. Keep the flight controller nice and tight. And very lastly, but not least, we're going to take a little bit of CA here, and we are going to drop it just right on the threads of the standoff posts and the nut, just so that it won't come loose in flight. Let that dry. That's it. Step 9. Step 10, motor installation. So we have our Outlaw power here, Outlaw power motors here, 2212, 1400. We are going to bolt the motors onto the top of the aircraft using 2 of the 3x16 bolts. Sorry, excuse me, 3x14 bolts. 3x14. It's the middle sized of the 3mm bolts that are included in the kit. So 3x14. And I recommend using Loctite. Some people aren't a fan of using Loctite on motors, but these really don't get too hot, so it's not going to hurt it. So we're going to install the bolt from underneath, 3x14. And as far as the wire direction, so as you can see here, if we look at the top of the model, so this is the front. The arms are designed in such a way so that the motors can be mounted either way. It can accommodate the small bolt spacing or the large bolt spacing. So you can mount your motor any way you want with the wires hanging out. It really doesn't matter too much, if you can see that there. So just bolt it any way that looks good. Sometimes I just prefer to bolt them outwards. So if this is the front of the aircraft, all the wires face to the outside of the model. I think that's what I'm going to do in this case, just for aesthetics. So we will bolt the motors on. Using the washer as well. Make sure we use the washer on the bottom side. Tighten them up. And a final check on the motors, make sure they're all nice and tight. There we go. Step 10, motor installation complete. Step 11, time to install the Outlaw 5-volt 2.5 amp BEC. And we're going to install some zip ties which hold the speed controllers into the frame. So the BEC, make sure you grab this one. It's got a servo plug on one side and it's got a red 2-pin JST plug on the other side. So what we're going to do is we're going to flip the model around, and the BEC is actually going to be installed on the underside in between two of the zip ties on one of the speed controllers. It can really go anywhere. I think for the manual's sake we put it on the right side. So upside down front, we put it upside down here. So that's where the BEC is going to go. But first what I'd recommend is putting in the zip ties. So you're going to take the zip tie, you're going to, just as the manual states, put it through the top hole and through the bottom and let it sit just like that. Speed controllers will drop into place, tighten them up, cut away the rest. Pretty simple. So we included all the zip ties in the kit. We're going to install all 8 here. So this is the back. Okay, and now it comes to that, to the side where the BEC is going to go in. The BEC is just going to simply slip right in between 2 of the zip ties. Okay, and the fronts. The fronts can be a little tricky. You might want to use a little pair of pliers or hemostats or something like that, but I think we should be able to get it here. Okay, so now that we've installed all 8 of the zip ties, so again, we're going to flip it over. BEC goes on the underside, so you can actually slip it in from the top, as I found here, while building some of these models. So you can just slip it into the top, make sure the wires are down, make sure the wires go below, and we'll have the logo facing downwards. Makes it look a little nicer. Make sure the wires fit in place. Just pull it through. So as you can see there, the BEC is in place on the underside of the airframe under the 2 zip ties. Next we will install the speed controllers on the top. But that's it. Step 11. Now lastly, we are going to have the power wire from the BEC come out through any of the holes, whatever hole's easiest. So power wire here. We're going to take it around and plug it into the NanoWii at this point, and as the manual says, black wired down. So if we're looking at the top of it, the black wire is going to go on, it's going to go plug in on the far right port. This is for power right here. Black wire down. So you can see here the black wire is towards the bottom of the board. And that is it. We have now successfully installed the BEC. Lastly, we will connect the power distribution board to the BEC, as it says in the manual, just red to red, black to black. Pretty simple, and we can take this wire and just kind of hide it under the frame. If you wish, you can put the zip tie wires through it, but we can just leave it inside the frame. We can just tuck it away for right now. So we plugged in the BEC wire into the power distribution board to give the BEC power. We've also plugged in the wire here into the NanoWii. Step 11, complete. Steps 12 and 13, kind of one and the same. We're going to install the 4 Outlaw Power speed controllers. So what happens is these go in the frame in a square configuration, and we're going to run the wires through the top frame and out the arms and plug them into the motor. So as the manual says, we're just going to connect the ESC wires to the motor at this point, just kind of arbitrarily. Then what we're going to do in step 13, you're going to fasten everything. You're going to fasten the zip ties on the frame, and then you're going to put 2 zip ties on the arms to attach the arms to the frame using a zip tie. It's nice if you bend an arm or something, you just simply cut the zip tie, put another one on there. So here we go. So we've got front of the aircraft here. It's pretty simple. What we're going to do is we're going to run the signal wires here. We're going to run them down the hole. Okay, 1, 2, 3 at a time. So we're going to run these down the hole. And on the bottom side, we're going to have them come out. Okay, so we're going to have it come out here. Now the same speed controller here, we will take in the other hole. So on the one hole to the right here, we're going to have the 3 wires coming out. Now this hole, we're going to run down the positive and the negative power wires, just like that. Now the speed controller will be able to be strapped into place. So I will do this right now using our zip ties that were previously installed. So I usually kind of line up the sticker. There we go. Tighten the zip ties. And just leave them a little loose. You don't need to snug down on the zip ties right now. Now on the underside, we are going to take the power wires, black to black on the power distribution board, red to red on the power distribution board. So as you can see here, we just plugged in the wires into the power distribution board from the speed controller. So this is what's going to power the speed controller. Now at the same time, we're going to prepare for the following steps. We're just going to leave these be, but these eventually are going to, the signal wire here is going to plug into the NanoWii. But for this step, we're not plugging it into anything. So we will repeat that times 4. So the next one, we will repeat in a pattern. So we're going to put in the motor wires here. So as you can see on page 13, there's going to be 5 wires per each grommet, except one grommet will have more because you will have the wires coming out from the BEC. So this grommet, for example, shares lots of wires. So the power comes here from one of the ESCs, and in the same grommet we've got the motor wires going to another one, the motors. And for right now we will just plug in the ESC into the motor arbitrarily. We'll check directions later. And we'll do it from the other motor that we just installed, the speed controller. Just plug them in, get them tidied up a little bit. Okay, now the power wires. And we will leave the signal wire up top. Plug it into the distribution board. Underneath, red to red, black to black. You can see here, we plugged it into the power board. We will tighten the zip tie. Okay, we'll repeat for the other 2. Okay, now we're just going to triple check and make sure we got everything plugged in right. So we're going to check 4 speed controllers on the top frame, all securely zip tied into place. Okay, the next thing we're going to check is that all of the motor wires come down through the grommets and they all go out to a respective motor. And just plug them in at this point, just an arbitrary check. Next, we're going to make sure that we've got all 4 of the speed controller signal wires here in our hands. Yep, this is going to plug into the NanoWii in future step. And lastly, we've got the power wires all coming down, and they plug into the power distribution board underneath. Triple check the polarity, red to red, black to black. Quite simple. So once you have done that, you have successfully completed steps 12 and 13. This is 12 and 13. Add the zip ties. Finally, once we've got everything strapped down and set up into place here, we've got our zip ties attached. To finally complete step 13, we are going to install 2 zip ties on the arm on the underside. So I recommend flipping the model over. It makes things a little easier. And we are going to run the wires on the underside of the arm. This way, when the canopy goes on top, it won't crush the wires, or it'll make it easy. Now also, we mentioned to put the zip ties in between the 2 bolts here. This is where the canopy bolts will go in. It goes on the inside hole for the small portion of the canopy, so for the back of the canopy, and it goes on the further outmost hole for the front of the canopy. So put the 2 zip ties in between these, makes it easier. So usually I put the zip ties right on the edge of the speed controller wires, right here. One right here. Another one right here. So we've got our 2 zip ties in between the 2 holes on the bottom side. Repeat all the way around. Okay, once they're all strapped down, we will cut all the zip ties from this step. And we will cut the zip ties on the top. Okay, now to confirm that we finished step 12 and 13, let's take a look here. So we have 4 speed controllers on the top with a BEC on the bottom for one of them, with the zip ties holding them all in place. We've got the wires running down through the grommets. Each grommet will have 5 wires. 3 of the grommets will have 5 wires, 3 of the motor wires, 2 of the power wires. 1 grommet will have the extra wire from the BEC. They'll go down through the frame, and all the wires will come out to a motor. The speed controller wires will come down to a particular motor, and then it is zip tied in place on the arm here. Lastly, the speed controller power wires are plugged into the power distribution board, red to red, black to black. And we've got the signal wires coming out from the speed controller on the top frame, ready to plug into the NanoWii on the next step. So that is it. Step 12 and 13. Step 14. Now we're going to plug the speed controller signal wires into the NanoWii. Now, this is very, very, very important. If you glance ahead to if you glance ahead to the next page, on page 19, we have a big red stop sign. And we say, what we just told you A lot of the guys did it wrong in the manual. So really pay attention to this step. So we are going to trace each motor back through the speed controller wires back to the speed controller to its appropriate signal wire. Then we are going to plug it into the NanoWii in a very specific port. If you plug this in wrong, what will happen on your first flight is your model will simply just flip over and crash. Seen it happen a bunch of times, and we're trying to make that not happen. So here's how we're going to do it. So on our manual here, you can see we have A, B, C, D ports. That correlates to A, B, C, D on the back of the NanoWii right here. And we are going to plug them into the appropriate motors, the speed controller controlling the motor on the manual here. So for example, let's start with A. So this far left port right here. It needs to control this back right motor right here. So we want to control this back right motor, and this motor, the speed controller that controls this motor, we want that signal port to plug into port A right here on the NanoWii. So let's do that. So A is the back right because the arrow is facing forward. So the back right motor, we're going to follow the speed controller wire through here, and then it comes through the frames here. So for example, for this model right here, it's this speed controller controls this motor. Therefore, this wire right here is going to plug into the first left port on the NanoWii. Once again, the black wire is down. The black wire is down just like the BEC wire that we previously installed. Signal, the white wire is up, black wire is down on the far left port. Okay, that was easy enough. So now let's do B. B is the front right motor right here. So once again, I'm going to trace the motor wires coming back into the model. So that comes here into this speed controller, and this one right here. So this wire right here is for this motor. This is going to plug into B. So I'm going to plug it into the second one over. Okay, so now we're going to keep going around. So C is the back left motor right here. So this is going to plug into the third port from the left. So I'll follow the wires right here. The wires come up through the frame to this speed controller right here. So this wire controls C. So this is port C on the NanoWii. And lastly, process of elimination, we will triple check. D is the front left motor, and that's going to be the fourth port from the left, so it's going to be the one right next to the BEC. Please also note we've got ferrite rings here on the speed controllers. Now usually people say, oh, I don't need those stupid things, let's just cut them off. Well, we found a lot of stuff in our speed controller testing. I'm just going to say you might want to leave it on there. For this reverse speed controller testing, you might want to leave it. So please leave the ferrite rings on there. Do not cut them off. So we can triple check that we got it complete here. We've got all four wires plugged in and the BEC. Now once again, if you glance to page 19, it says stop. Please check this once again, because when we let our buddies build them here in Orlando, a lot of them got it wrong on the first shot. So once again, we just say, hey, take a look at it, make sure you retrace your motor wires to the NanoWii and make sure they're exactly in the right ports. So it might be worth another minute to retrace the motor back through the frame to the speed controller. Make sure it's plugged in the right port there. But if you're good to go, that's step 14. Okay, for step 15, we're going to install the flight controller cover plate, the protector plate, and install adhesive Velcro on the battery. So I just installed it. It's the furry side on the battery. So install the adhesive Velcro on the battery here. So you're all set, good to go. And lastly, we will install the flight controller cover plate over the top. We made a little cutout, as you can see here, so that the the plugs from the ESCs don't hit the cover plate, so that it can really bolt on anyway. A little bit of blue Loctite, and we're good to go. cover plate is on. Step 15 complete. Now it's time to install the Spectrum satellite if you're a Spectrum user. For those of you who are using the external receiver, just continue on to the next step. But for you Spectrum users, here I've got another model here. As you've noted, we've been building a one with the external receiver for the purpose of this build video, so I had to grab another model here. So please, that's where this just appeared. So this is a Spectrum NanoWii right here. This one, it's got the 3 wires here for the satellite, and it's pretty simple. So what we're going to do is we're going to plug in the satellite jumper wire that comes in our kit here. So the satellite jumper wire is going to plug in with the red wire facing forward. So with the arrow, the red wire faces forward, as you can see here. And then there's only one way to connect this to a satellite. So it's going to plug into a satellite as such. So it's a very, very simple connection here. It's going to plug into the satellite. So as you can see here, we've already done it on this one. So it's going to plug in, and then we just grab some double-sided tape right here. Some of this 3M stuff, this stuff's great. And just tape the satellite on top of the flight controller cover plate. And that's pretty much it. That's step 16 right there. Step 17, the external receiver connection. So I'm a Futaba guy, so here I've got just a standard 8-channel receiver. For those of you with Futaba, unfortunately we can't use S-Bus. We have to use just a 1-wire to 1-wire connection for an external receiver. So any 5-channel to 8-channel to 14-channel receiver will work. For those of you using JR DMSS, unfortunately at this time we've got to use an external receiver for you guys as well, along with a satellite. Hitec guys, same sort of way, so it's an external receiver. So this one here is an 8-channel receiver, and we've included some wires here. So this is how the connection is going to go. So we can start first with the throttle wire. It's pretty simple, not too difficult. So we've got a 4-inch male-to-male connector right here. So what I'm going to do is I'm going to plug this into channel 3. With Futaba, we're channel 3. So this plugs into channel 3 right here. Now this, the jumper wire, is going to plug into the vertical port on the NanoWii, as you can see right here. And it's going to plug in with the black wire facing up into the NanoWii. So I just plugged it in just like that. You should be able to see the connection right there. Next, what we're going to do is we're going to run the 4 individual white wires to these 4 wires right here on the NanoWii. Now you've got to be able to know your channel assignment on your radio. For Futaba, I'm going to list this out for Futaba, for example. JR, please refer to your manual so that your aileron, elevator, rudder channels plug in the correct way. So what I'm going to do here with the 4 white wires is I'm going to plug them in into the top of the receiver where the signal port is. So similar to where the white wire is on the receiver, these wires are going to plug in on the signal port because it does not need any sort of BEC power. It just needs to get the signal to the NanoWii. So as you can see here, I just plugged it into the receiver, into the signal port on the actual receiver itself. So the signal port is plugged in there. Now, channel 1 for me, if you look at the diagram on the bottom left of the manual, page 22, it shows you the positions where each of these white wires needs to plug into on the NanoWii. So starting on the bottom of the NanoWii, you can see the aileron wire is first. So for Futaba, aileron is channel 1, so I'm going to plug this into channel 1. Next, going up, it says elevator, so the next one from the bottom is going to be elevator, which is channel 2 for Futaba, so I'm going to plug this in here. Okay. Channel 3 is throttle, which is plugged into the bottom port, the vertical port already. You can refer to the manual, there's a pretty clear diagram right there. Next is rudder, which is channel 4 for Futaba, so I'm going to plug rudder in right here. And very lastly, I'm going to plug in my auxiliary channel. In this case, I'm going to plug it into channel 5 on my receiver. I'm then going to program my radio as channel 5 as this auxiliary channel. So you can see here I've got my connections all plugged in, so it's plugged in as such. Now once again, if you're a JR user or a Hitec user, you want to triple check the connections and make sure that your aileron, elevator, rudder, and aux are plugged into the correct channels here on the receiver. Lastly, we're just going to get a piece of the double-sided tape, and we're going to tape the receiver here onto the top of the flight controller cover plate. Not on top of the flight controller, that would be bad. Top of the flight controller cover plate. So we're just going to cut some tape and we're going to put it up top there. So this is it. And it's installed. Okay, that's it. Step 17. Step 18, A, for those Spectrum satellite users. So here we have a Spectrum DX8. From what we've found in our testing, the NanoWii will work with both DSM2 and DSMX. But we found some kind of weird stuff in here, so please pay attention. A radio such as like a DX7 or DX7 SE will work with DSM2 without a problem. They were designed for DSM2. But what we found is that some of the radios that are backwards compatible, such as a DX8, DX9, maybe even the 18, that will generally work backwards compatible with DSM2, don't seem to be connecting too well with the NanoWii. Users will simply just not be able to get it to ARM. So what I'd recommend is that if you have a radio like a DX8 or DX9, if it says DSMX, please use the DSMX satellite. This will just simply eliminate any sort of confusion that there might be. But for those of you with a DX7 or DX6, the DSM2 works just fine. So they've got to be kind of paired that sort of a way. So now in step 18, we show you how to set up the radio. These steps are very important, so please follow pretty closely. So first what we're going to do is we're going to turn on the radio, and here you can see we've got the Invertix model. So as you can see in our radio, it says create a new helicopter in the radio. Helicopter model in the radio. Okay, we've created the helicopter model. Using an external receiver, you have to bind your satellite. So as I mentioned before, you have to pre-bind your satellite before you connect it to the Invertix. So that means you've got to get the bind plug out, get an external receiver, go to this new Invertix model, bind your satellite, then you can reinstall it into the Invertix. Now what we're going to do is we're going to go into the flight mode switch. I need to go into the menu here. So we're going to go into the flight mode switch, and we are going to make flight mode work for our idle up. So what I'd recommend is putting flight mode to F mode right here. So this is actually what's going to arm our NanoWii to get it to turn on. If without arming it, it will not work. Now while we're at it, I go in and put hold switch to hold. That'll be covered in a different series of videos showing how to get both idle up and throttle hold to work. So while we're still in this menu here in the system setup, what we're going to do is we're going to go into the switch select. So we already did hit flight mode to F mode. Next what we're going to do, and we're going to go into switch select, and we're going to make sure F mode is auxiliary 2. Auxiliary 2 is what we want here. So once aux 2 is set to flight mode, we are ready. Everything else can be inhibited. Not a problem here. So we'll go back to the main menu. So now what we're going to do is enter the servo reverse. So I'm going to go here to servo setup. I'm going to go to the reverse channels and just follow the diagram here. So throttle's normal, aileron is reversed, elevator is normal, rudder is reversed, aux 2 is normal. So you can see as I have here, reverse as I go through each of these. Just please reference the manual to which channel should be reversed. Pretty simple. Now, what we're going to do is we're going to adjust the endpoints. Here's how the endpoints work on the NanoWii. The NanoWii works very similar to a old school flybar helicopter, if you will, or just any sort of an airplane or anything. Meaning if you take a particular channel, so let's say aileron, and you increase the endpoints from 100 to 110, it will simply flip faster. If you reduce them, it will flip slower. You can add all sorts of stuff like exponential or dual rates. You can do any of that stuff. So the flight controller, as sophisticated as it is, it's quite easy to program here on the radio. So what we're going to do now is we're going to reference the chart here on the endpoints, and we're going to adjust the endpoints so that we can get the kind of feel that we want. So first, the most important is we're going to go into the servo setup on the travel. We're going to go to the aux2 channel, which is our switch to enable the motors to spin, and we're going to crank that up to 150, 150. Because I want, when I flip that switch, it's sending a signal to the MultiWii saying, hey, we're ready to arm. And it's just safer if we open up the endpoints all the way. So we're going to make aux2 150, 150. 100, 100 will work, but 150, 150 is a lot safer. It'll get that signal all the time. Then it needs to be in that flight mode, or it needs to be in the shutdown mode. So once we've done that, we're just going to follow the charts here. Just follow the endpoints, beginner and advanced, so you can see various different endpoints for the aileron, elevator, or sorry, the travel setup, for the aileron, elevator, and what have you. So you can adjust your travel for all sorts of different channels. Now, I guess the last thing that I should mention is the travel on the throttle channel. The travel on the throttle channel is pretty much just like setting your power. On these speed controllers, you cannot set the endpoints. There's no logic to be able to set the endpoints. So what we recommend is just adjust the endpoints on the throttle channel so that the power feels correct to you. So I'd say start around maybe 120, 120, 125, 125, somewhere in there, and then you can increase or decrease the throttle channel endpoints to get more or less power out of it. I have a feeling most of you are going to want full power, so you're just going to go to 150, 150 and adjust accordingly from there. So adjusting the travel on the throttle channel just gives you more or less power. That's pretty much all it is. Other than that, just reference the guide here on the chart that we've got here in the manual, and you should be good to go as far as the proper feelings there. So that's it. 18 for satellite. Okay, now time for the external receiver users out there for the radio setup. I'm going to group this together for both Futaba, Hitec, and JR because all the external receiver, the radio setup's very similar. The only thing that changes is the servo reverse direction. So the JR users and Futaba users, it's pretty much the same sort of thing. So here we go. So here I've got my 14SG. This radio is going to be controlling the Invertix here. You can use anything, like I said, you can use any sort of a 5-channel radio, 6, 7, 8, up to an 18-channel radio for the Invertix. You just need 5 channels. So we need 4 channels to control it, and a 5th one with an auxiliary to arm and disarm the NanoWii. So here's what we're going to do. If you follow the manual here, the first step is to create a new helicopter model in the radio. So I've done that here. As you can see, it's a helicopter little logo right here, and it's called the Invertix. So you've seen I've already done it. What I'm going to do is I'm going to assign a channel for the auxiliary, which will control the NanoWii. The NanoWii needs to see the auxiliary channel go to one end of the extremes to arm it. Once it's armed, it's always in 3D mode, so it's always going to work both ways on the throttle stick direction. So it's either motors spin and will reverse both ways, or motors completely off. Now I'm going to assign that on the same channel that I plugged in that auxiliary wire on the previous few steps. So if you recalled, when I plugged in the channels into my receiver, I plugged that auxiliary wire from the NanoWii onto channel 5 in my case. It could be channel 6, 7, 8, 9, 10. It could be anything you want. But I always just choose channel 5 to make life a little easier. So what we're going to do is we're going to go into the radio here. So I'm going to go into the function menu in Futaba, for example. And I'm going to go down and I'm going to call channel 5 an auxiliary channel. So I called it aux 8, but it can be aux 1, aux 2, aux 3, aux 4, something like that. And what I'm going to do is I'm going to put that to my idle up switch. So in my case, that's switch E right here. So as you can see, I programmed channel 5 to switch E. So that's going to tell my idle up switch, that makes my idle up switch the switch that will make the NanoWii either disarm or arm. So there we go here. Now what we're going to do is we're going to go in and we are going to make sure that I can go to my servo monitor and make sure that when I hit the idle up switch, it makes channel 5 throw one way or another in my servo monitor here. You can see that. Okay, great. Now next what we're going to do is we're going to go into the reverse screen here, and I'm going to make the channel selections exactly as the manual says. So for Futaba guys, aileron, normal, elevator is reversed, throttle is reversed, rudder is normal, auxiliary channel is normal. So that's for you Futaba guys. Now if you're a JR guy, you look on page 25, your channels are different. So please adjust your channel reverse screen to the appropriate channel so that everything is how it should be. So the next thing we're going to do is we're going to adjust the endpoints. So now it's time to talk about the Multiwii. The Multiwii acts just like a traditional helicopter, or traditional airplane for that matter, meaning you can adjust the endpoints on a particular channel to get the overall feeling faster or slower. So for example, if I want a faster flip rate on the elevator, let's just say, instead of having my endpoints at 100, 100, I'm going to adjust them to 115, 115. It's the same for aileron, elevator, and for rudder. It's very simple. Now for the throttle channel, what we're going to do is we're going to adjust the overall power of the model by adjusting the throttle channel. So we're never going to do any sort of calibration on the speed controller. Simply there's no logic in there for that. So the throttle channel rather just acts as power. So if you want full power out of your speed controller, just crank up your throttle endpoints max, 140, 140. Or for JR users, 150, 150. Just to begin, I think we recommend in the manual here around 120, 125 or so for the throttle. That'll get you started, but if you want more power, just crank them up. Lastly, what we're going to do is we're going to go to the endpoint menu, and this is very important. We're going to go to the endpoint menu, and we are going to go to that auxiliary channel. So for mine, it's channel 5, aux 8, for example. And I'm going to crank up those endpoints to maximum. So I made them 140, 140, as you can see in this case. So when I flip my switch back and forth, you can see it changes my endpoints. Now this is done simply so that the NanoWii gets a good signal for the radio, whether to go in all motors on or all motors off. It's just 100, 100, it works just fine, but by increasing that endpoint on the aux channel, it makes it just a little bit safer, whether it's in flight mode or disarm mode. So that's what we got right there. You can adjust your endpoints at any time when you're flying just to get a good feel for the model, to get your cyclic rates how you want them. So that's it for the external receiver radio setup. Okay, now it's time to finally power up the Invertix. So here we're going to be covering steps 19, 20, and 21. So as you can see here on the manual for page 26, we've got a big red warning label. Pretty much it's just explaining that the Invertix is really different from anything else you've probably ever flown. We wanted you guys to really pay attention to these details and everything listed in the manual, because I mean, it can really do some serious damage here, either to the model itself or to somebody else. So please pay attention here. So in step 19, we just discussed the NanoWii spool up process. So this is it in a nutshell. This is how it works. So what happens is you're going to take your auxiliary channel. So for example, mine is set to my idle up switch here on my radio. You're going to take the auxiliary channel, and the Multiwii is going to arm when the aux channel is thrown to one side. So for example, in my radio, it's set up right now where it's normal mode and idle up 1. So if we're going to equate it to helicopter terms, normal mode and idle up 1, nothing happens. I can move my stick all around my throttle stick or my cyclic stick, nothing will turn on. Now once I go to idle up 2, it will arm once the stick gets to half throttle, once the throttle stick gets to half throttle. So this means that once it arms, it's always on. It's always either in forward mode or reverse mode. So this means that you've really got to be careful if it's sitting on the bench and you hit the switch by accident or something like that. You know, just make sure you know how this is going to work before you get going. So this is why we haven't installed props or anything like that yet. So the other thing that means is very carefully raise your throttle stick, because what happens is the speed controllers, the Outlaw Power speed controllers, have a slow start process, and we did that for safety reasons. So what happens is as soon as you bring your throttle stick up to about mid-throttle, the spool up process will engage, and it takes about 2 or 3 seconds for the motors to fully spool up. After that, it's going to react to wherever your throttle stick is. So this means that if you spool up and go to full throttle while it's still spooling up, it will then finish the slow start, then immediately go to full throttle, because that's where you told it to go. What does that mean? That means it's just going to take off, just go completely, fly away from you. You'll still have control, but the whole thing will just take off the ground. Well, we don't want that. So what I'd recommend to everybody is you go to your idle up 2 switch or your flight mode switch. So you flick it into flight mode, slowly raise your throttle stick till you hear the motors engage. Once that happens, just stop. Don't move any more throttle. Don't give it any more commands. Just let it sit for a few seconds, and you'll hear it when it engages into its flight mode. So let's take a look at that. So we're going to take a look at that. We're also going to take a look at setting up the motors, getting the motors spinning the right way, and putting the props on. That's what we're going to do here. So we've got our external receiver model here. This one's with my Futaba radio. This is the model we just built. So I'm going to plug in the battery. 3-cell battery. Okay, now that's the beeps that we want to hear. Once again, this is what we want to hear. We want to hear da-da-da, da-da-da-da-da. Okay, now that last set of beeps that you just heard, if for whatever reason you don't hear that, you probably got something goofy going on with your satellite connection for Spectrum users, or for external receivers. Somehow you didn't get everything set the right way, because that has to do with bit binding to a radio. But as soon as you hear those sounds, that means it's got a good signal from the radio. So that's what we want to hear every time we turn it on. Now, for whatever reason, if you don't hear that second kick, just unplug the second set of beeps, unplug it, plug it back in, and you'll be good to go. Okay, great. So now what we're going to do is I'm just going to show you basically what I was explaining earlier with the spool up process. So we got nothing in normal mode. So this is my flight mode switch here. Nothing in normal mode. So you can see I can move my sticks all around. I've got nothing at all. Now I go to idle up 1, for example, and I still have nothing. It only arms when it's in that full position. So I'm going to go to the second position, and I'm at half throttle. And it spools right up. Now I'll show that again. So I'll go to my idle up 2 position. From 0 to mid stick, I have nothing. I have nothing at all. Now, as soon as I go to half throttle, it'll slowly spool up. Slow start. Then it will engage. Now once it engages, I have full throttle, full control over my throttle, both in the positive direction and in the negative direction. So as you can see, the motors completely stop and reverse at half throttle. So anything mid-stick and above, the motors are going to spin the right way for upright flight. Anything half throttle and below, the motors are going to spin the proper direction for inverted flight. It's very simple. So the reversing is all done by your stick. Your stick is telling it when to reverse and stop the propellers. So it's pretty crazy how much stuff there's going on at one time. So to reiterate the slow startup process. So flight mode, very slowly. Once you hear it kick in, stop feeding in throttle, and it'll just slowly spool up. Okay, now we have full control. Now, if you do what I said you probably shouldn't do, so let's just say if you were impatient and you just go to flight mode and you get full throttle, what that means is it would do the slow start and then bam, it would just lift off the ground. It would look something like this. So full throttle. So you can see it instantly did a slow start process, then bam, to full throttle. So make sure your stick's around half throttle when it's spooling up, maybe 55% if we want to get technical. So we know how it works now. So now what we're going to do is we are going to set the motor rotation direction. Now, as you can see here in the manual, page 28, we've got the arrows showing which way the motor should go. And also, we included a decal in your kit. We call it the Propeller Rotation Indicator Decal. This thing's great to stick on a toolbox or to stick on a radio case or something like that. So this way, when you break some props, if you got a little too aggressive or if you had a little boo-boo and you broke a prop and you need to know which way the motor direction needs to go and which way the propeller needs to go, you can just refer to this thing. Obviously the arrow's forward and this is the tail. So that's how you can check it out. So this is how you know how your motors are rotating the right way. So we're going to refer to the manual, and I'm going to spool it up, and I'm going to make sure my throttle's above half. Like I want to make sure when I check the propeller direction that it's actually going, the motors should be going the right way. So I'm going to give it a little above half throttle, so like about right there. And I'm going to check them one by one. Now the way I check them is I simply bring my finger over to it, and it'll pull my finger one way or another. If you have a hard time telling which way the motor should go, you can wrap a little piece of tape around them and see the tape. It's a little bit more visible. So the front left should go to the right. So it's going to the left now. That's incorrect. So I got to swap that. This one is incorrect as well. This one should be going to the left. This one is incorrect as well. And look at that. Would you believe that? All four are backwards. I arbitrarily plugged them in, and I guess luck is not on my side today. So what I'm going to do is I'm just going to reverse any two of the motor wires on all of the speed controllers. In my case, I have to reverse all four. What are the chances of that happening? So I'm going to reverse that. And like I said, you really want to make sure that you've got the stick above half throttle. You want to make sure that it should be going the proper, it should be going this proper direction. And once again, when you're checking the motor direction, always make sure the arrow is facing forward, so you're looking at the front of the aircraft. Okay. Got it. So I just reversed all four. Arrow facing forward. Let's give this another shot, shall we? Okay, here we go. Above half throttle. Right. Right. Left. Left. Perfect. So now the motor direction is going correct. So we've got page 28, 28's all set. So step 20, however. We got through step 20, not a problem. So all the motors are spinning the right way. So now we're good. Now what we're going to do is we're going to check the compensation direction and make sure everything's plugged in right. This is the easiest way to do it. So what we do is we explain to check the aileron, the elevator, and the rudder. The rudder's a little bit harder to see, so you might want to once again add a little bit of a little tape or something like that. But pretty much what we're going to do is we're going to spool it up and we're going to get the throttle to around half stick. Then we're going to check the aileron direction, elevator, and rudder. So let's take a look. Spool it up, half stick. Once again, above half throttle is a little easier. So now, when I give aileron, for example, if I bring it to the left and I hold it, I want my left two motors to slow down, which it does, and my right two motors should speed up. So that way it's wanting to bank it to my left. My left, not your left. My left. So these two should slow down. This will speed up, which left, the whole aircraft will rotate to the left. So the aileron is set the correct way. Now, spool up again. Now we'll check the elevator. So if I push it forwards, as if I'm going to do like a front flip, my two forwards should slow down. My back ones should speed up, which it did. Now, when I do the rudder, if I put it to the left and hold, the front left and the back right should speed up with left rudder. So front left, back right should speed up. That is correct. And to the right, they should slow down. And that's it. So we've just checked it now, where everything is it seems just about right. All the directions seem good. All my connections are good. Now, if any of these circumstances were not to pan out how they should be panning out, what you'd want to do is you'd want to go back, as we mentioned in the manual here, check step 17, where if we go back here, 17 is where we attach the certain channels into the external receiver for your external receiver guys, where we had the channels plugging in there. And if anything's ever goofy, you're going to want to change the back 4 motors where they plug into the NanoWii. If something is not right or if it's way out of control, maybe you got one of those backwards. So you might want to refer to that step once again. So now what we're going to do is we're going to grab our propellers. We're going to install them. Very simple. The props have an arrow on them, 2 spin clockwise, 2 spin counterclockwise. Match up the propeller to the diagram and get them to spin the correct way. So if this is the nose, the front left should spin to the right, so it should spin clockwise, as should the back right, so they will both spin the same direction, so front left, back right, spin the same direction, and the opposite, counterclockwise on the front right, counterclockwise on the back left. Put these on, we're going to tighten up the nuts. Lastly, we'll just put the lock nuts on the top here, and we're just going to tighten with a 10mm wrench. Now, these propellers are somewhat, they're not brittle, but they're approaching the point of being brittle. So what we do is we recommend you just hold the motor with your hand and try not to touch the propeller if you can while you're tightening it, because it can snap if you hold the propeller while tightening it. So just give them a good tighten up, crank them up as hard as you can, honestly. These things will reverse in flight and will try to loosen themselves. So simply just tighten them up. Now you're good to go. And when we're outside, we're going to triple check and make sure the directions are all going the right way. So just tighten them up with the 10mm wrench. We're about ready to fly. Let's do a canopy now. Let's fix up the canopy. And the final few steps here, step 22 and step 23. Applying canopy decals and mounting the canopy on the multi-rotor. So here we've got our premium large decal sheet here. Once again, they might vary. We've got a few different types of these decals that are coming with the kit, but essentially we're putting the same ones on here. So first what we like to do is we like to put on the windscreen. Now, this is a canopy that can mount in any direction. So that means you can make whatever you want, forward or backwards. Through our testing and through the design process, I always saw the color as the front. So whatever I see as the color, I want that to be the front. And I see this as the tail, because, I mean, let's be honest, it looks like a tail, honestly. So, but you can dress it up however you like, and the canopy will mount on the model. And you can even mount the canopy sideways. And you shouldn't do that, but you can mount it. You know, it's a quadcopter, so it can mount in one of 4 ways. So first, what I recommend doing is putting on the windshield, I guess, the windscreen, whatever you want to call it. So that's this little triangle piece here. That one we're going to mount here. Now the way these decals work is really cool. You just cut them out, and it's got an applicator sheet, and it's also got the peel away sheet. So what you should do first is peel them away, just as such, so the hard side with the graph paper on the back is just going to go. So we're just going to get rid of that. And then what we're going to do is we're going to roughly line up this to the front. And we're going to center it. And I am horrible at doing this straight. So we're just going to set it on the canopy as such. Then we're going to push it on with our finger. And just push there and try to even out. Even it out, get rid of all the bubbles. Get rid of all the little air bubbles that might be in there. And then simply we are just going to peel away the paper. And voila, we've got it. Just like that. Easy as that. And also on some of these decal sheets, we give you more than you need in case you screw up a few. So that one really helps with the orientation. Seeing that big black windshield on there really helps. Lastly, what we recommend doing is putting on the Invertix 400 in the back and the Encore RC on the side. There we go. So the Invertix 400 is up there on the top. And we like the Encore C stickers on the sides. We think they look pretty sharp. But obviously, this is your canopy, and you can do whatever you want with it. You don't have to put any stickers on there. Like that. Where'd my other sticker go? There it is. Stick my scissors. Peel this off. This one here. Whoops, the C got left behind. And that's it. That's fixing up the canopy right there. So applied the decals, done. I got some left over. If you have any left over, once again, great for toolboxes, radio cases, however you want to help out our brand by showing your support. And we thank you for that. Okay, and the very last step, I don't need the manual for this one. I know how to do it. So we're going to take the canopy. Once again, the arrow faces forwards. And because of that, we're going to put the canopy on with the color facing forward. And it looks pretty awesome. And the canopies are attached with these guys, just little plastic thumb screws and little nuts. It's just the cheapest, lightest, easiest way to mount a canopy. And you're hardly ever taking off a canopy yet anyway, because you can mount the battery from the bottom. So just 4 little bolts and secures the canopy. There you have it. Completed Invertix 400 model. This was the complete assembly of everything. This guy is now ready to go. So what we're going to do is we're going to charge the battery up. We're going to go outside and we're going to fly this thing. So that was the build instructions. Now let's go fly it. So here we are, we're out at the field, out of the build room, and this is it. This is what we just built. This is the Invertix 400 ready to go. So a little pre-flight things we're gonna check here. Number one, make sure that the propellers are tight. We can just go around and just check by hand. Because of the lock nuts, they shouldn't loosen up, but they can after time, so make sure that they're certainly tight. Next is the propeller direction. The front left and the back right are spinning the same way, and they're both spinning to the right. Make sure your propellers are on as such, and the front right and the back left are spinning to the left. They're spinning counterclockwise. So that's pretty much it. So what I'm going to do here is I'm going to show you how we're going to spool it up, how the spool up process works, and then just show you a little bit of what it can do. We've got our 3S 2200 milliamp battery here. This one's a 45C. I'd recommend anything at least 30C, 35C. Obviously more is better if you can afford it for this model. 2200 to a 2600 3S battery is about best for right now. Other than that, this is completely stock. Once again, the color is forwards. That's about it. So here we go, let's go fly it. All right, so we're gonna plug the model in here. And we want to hear the proper beeps as I showed you in the build video. Perfect, so we're ready to go. So what we're going to do here is we're going to flip it into our idle up, and then once we flip it into our idle up, we're going to bring it to half stick. At half stick it's going to arm, and we are going to be ready to fly. So here we go. So here you can see my idle up switch here. I'm going to flick it. Now I'm going to go to half stick. Right at half stick it'll begin to spool up. Don't give any more throttle. Perfect. So now you can see on the ground, you can see the propellers reversing right around center stick. So that means we're ready to go. So we'll bring it up into a hover. Now the first thing we want to do in the very first spool up is just lightly on the ground, we just want to just check our directions. So right makes it go right, left makes it go left, forward, and backwards. If this is correct, then we should be good to go. That means all of our directions are correct, the motor directions and everything like that. So we're slowly lift up into a hover. So here we go. Now, because we're not plugging this into the computer, it may require you to trim the model a little bit. This one I've already done some trimming on the model, but you know, it could require a little bit of rudder trim, a little bit of aileron trim. So it's real simple, just use your trims right here and just adjust it till it's a hands-off hover. So you can see here, relatively hands-off. I mean, just the same amount as like a helicopter or something. So once we've got it trimmed, we can just adjust our rates and we can just get the feel for it. So here you can see I'm obviously giving a rudder command and it's staying pretty flat in a pirouette. So I can adjust my rudder, I can adjust my elevator, I can adjust my aileron and get it comfortable. So now I'm going to fly it around a little bit. I'm going to flip it. Now you can see when I flip it, I'm just changing my collective direction, just like an RC helicopter. And it's pretty dang quick. Pretty darn quick. So let's fly it around a little bit. We can practice our inverted flying. And the nice thing about it is, this is the first flight on this model. And once you get your settings down that you want, it's just, I don't know, easy. It's just plug and play. And we can practice all sorts of stuff. Hovering maneuvers, stationary flips. Now what I think the Invertix is best with is to practice your hovering. So to practice your inverted hovering with your orientations. So like here's a nose-in inverted hover, for example. And here I can practice all of my orientations. Because the collective doesn't feel quite like a helicopter that we might be used to, we can just, you know, take our time with it and really practice the basics. But this thing's also really capable. I mean, as you saw, we can tick-tock. But it's quite a different feel, so make sure you fly it around a little bit, get the feel of it. We'll do a little speed run here. So you can see, it's fairly fast as well. So that's it. We're gonna set a 3-minute timer at first and check your battery after you fly. 3 minutes is usually about right when I'm banging on it pretty hard with a 2200 milliamp battery. Then when we're done, we're simply going to flick out of our switch and then we're done. So flip out of our flight mode. Now if I want to spool up again, I can just click back into idle up, spool up again, and as you can see, I have control over it. So that's it right there. That is the Invertix 400. That's the first flight on this thing. I really think you guys are gonna enjoy this. It's a fun model to fly. It's really fun to practice with. When you crash it, you hardly break anything. Crash parts people have been asking about: propellers, arms, and feet. That's really about it. If you whack it real hard, you'll break other stuff like a canopy or a piece of carbon or something like that. But that's it. We're really proud of this model, and we hope you guys enjoy it. Hopefully the build video was helpful for you guys. And if you have any questions, feel free to hit us up on Facebook, on YouTube, on email. Check out EncoreRC.com and Invertix3D.com. Thank you.